sad. Alright. I want to start by just, like, there's a few I kind of picked out, or will pick out as I'm looking at it. I don't even know if I'll do the whole problem, but just kind of start you off. So, this first one, I said it out loud yesterday, but it's probably easier if I show you. So, it's a 95% confidence interval. Margin of error is 0.08. You're looking for the smallest sample size. So, the question is like, okay, what's n? But it doesn't quite look like you have enough information. Because when you set up your formula, it'll be like z star times the square root of p over n equals 0.08. I can find z star using the inverse norm. I don't know p. So what I'm trying to like get across here is if you don't know p can be between 0 and 1. So if you don't know it, you just take the middle. Like if they don't tell you what p is, it is automatically 0.5 because that's just like the average of what it could be in your best case. Alright. Two, I had a few people ask what the point estimate is. So remember the point estimate is, so you can write confidence intervals like 0.4 to 0.8, I can go 0.6 plus or minus 0.2. I guess those are kind of the main two ways. But this number here is your point estimate. It's just your best guess. And all that is the average of those two numbers. The point estimate is just right in the middle. Is that okay for 1 and 2? I think 3 is fairly straightforward. 4, I think, is a jerk. So let's look at 4. Yeah. So they give you 95% confidence interval here. 0.087 to 0.133. And then they tell you in the next one, I know P is 0.4. And they're like, okay, what happened to the point estimate? What's going to happen to the width? So the point estimate, again, is like what's right in the middle of those two things, which is that 0.11. So the point estimate here is 0.11. The point estimate here is 0.4. So first of all, the summer is this. Which one's the summer? No, the summer one's the second one. So the second one, the summer one, has a greater point estimate because 0.4 is bigger than 0.11. Well, then it becomes like, okay, what happens to the interval? So you've got to think through this a little bit. With this one, you will have the square root for the standard deviation. You'll have the square root of 0.11 times 0.89 over it. That's for this one. For this one, you'll have the square root of 0.4 times 0.6 over n. N is the same, so you can basically disregard the n. But these two numbers, when you multiply them, will go into your standard deviation. Your standard deviation then gets multiplied by z star to create your margin of error. So if this piece gets bigger, what happens to your margin of error? It also gets bigger, right? And the width is just the margin of error double because it's like going in both directions. So I've got to figure out which one of these is bigger, 0.4 times 0.6 or 0.11 times 0.89. So the closer you are to 0.5, the bigger it gets. This is 0.24. This one is, I don't know exactly, but it's less than 0.24. It's like 0.09. So basically, there's an n on the bottom, I get that, but ignore it. This is a bigger standard deviation. This is a bigger standard deviation, which is going to multiply by z star to get a bigger margin of error and therefore create a bigger width. So it's therefore going to be wider. Is that all right? All right. Look at 13. First of all, because it printed kind of weird, but that's this is kind of crowded to look at too. But here, you look at the front side of 13. I'll show the back side. The front side starts that chart, right? That basically is an A here and a B here, just pretty goofy, so don't worry about that. But all they're asking about is candidate A. So none of this really matters at all. Candidate A. And they're saying, what would we use to figure out if, to estimate, to give a confidence interval for the proportion of people that are going to vote for candidate A. If I'm only worried about candidate A, am I concerned with one sample or both samples? Only concerned with one. The other way you can know that is we have not yet learned a 2 samples Z interval. All we've learned is a 1 sample Z interval, so it can't be any of those. Well, then it gets down to A or B. And this is like, do you understand what the point of this is? Are we trying to estimate the sample proportion, or are we trying to estimate the population proportion? Really hoping like 10 people would say population. I was. Let's do it again. Are we trying to estimate the sample proportion, which we just found and we know exactly what it is? Are we trying to estimate that? No. Or are we trying to estimate the big picture population? Yes! There it is. So that's how it should work. I'll tell you the answer. I'll repeat the question. Yeah. What's the question? What do you ask? It just asks you to. Did you turn the page? 334. Oh, each voter right here. What's the question? Like, I don't understand. Do you have any go through it? Okay. I know. Bowman's got you. Okay. Alright, give me another minute to look. And then I want to take like your questions also. Yeah, I don't know. The rest seem like sometimes you don't know there's an issue with the problem until you like get into it, right? And I didn't do the packet, to be honest. So just looking at it, I don't see anything that looks crazy, but that doesn't mean you might not get something weird. But what can I do? Do you have questions? You guys worked on it yesterday. You weren't like cruising through it, so I'm assuming there's some things I can go through. Or is it just yeah, Carter? 11. Okay. So I see 90% confidence interval. This is a way easier problem than probably most of you realize or think. I don't know. I got a 90% confidence interval, and I've got 34 out of 100. That is all I need to put it in the calculator and make the calculator do this problem for me. If you have the confidence interval and you have this will be your x, this will be your n, and you can literally just throw that in the calculator. And Carter, I'm not saying that to be like, oh, you should throw it. I'm saying like I think a lot of people didn't realize like it's simpler than it appears. So go stat, tests. Remember it's the one prop is the interval. And then it's 34 out of 100. Remember that this is how you type it in. Like a lot of people yesterday were putting like 0.34 here. Because that's the proportion. Like I get why you're doing it. But if you put a decimal here, it's going to get pissed off. It wants to take the two numbers and make its own decimal. And the confidence interval is 90, so put 0.9. And then it basically just tells you the answer. So that one is C. Carter, is that right? So yeah, use the calculator whenever you can. You can do that by hand, but it would take like a few minutes. You gotta find the star, multiply, and add, subtract everything. What else? Yeah. Well, thank you. see margin of error. I know P hat 0.6. I know my N is 900. So this is a little different one because what they left blank, they gave you P, they gave you the margin of error. What they left blank was Z star. So we're kind of going backwards from what we normally do. So I'm going to do the same like setup. Margin of error equals Z star times square root of PQ over N. That's just a general formula. The margin of error, so this is another thing I noticed yesterday. You've got to convert this into a percentage. Like if you put her into a decimal, if you put 2.7 there, it's not going to work. You'll get a number that's like 100 times bigger or smaller. But put 0.027 equals Z star times, and I know what all the things in the square root are, right? So I can figure this out. Because I thought 0.6, 0.4, and N is 900. So that's like 0.07, 0.27 equals Z star times. I got 0.016. Are people not getting it? Yeah, I'm comfortable with that. Now divide both sides by 0.0163. And I will get that Z star equals 1.65. And you're like, okay, great, but I don't see 1.65 as an answer. So you still have like an extra step. This is going to be the inverse norm of one of these things divided by 2. So you just check. And you don't have to check them all. Like, if this is too small, I'm going to go up. If it's too small, I'll keep going up. Like, the Z star gets bigger as you go. Some of you might remember it. Did you, like, try it, or do you remember it? Yeah, I think some of you, and like, okay, 95. You know what Z star is for 95? 1.96. So you kind of, like, start to get familiar with them. But if you're not, try inverse norm of, like, 1.8 divided by 2. And it'll be too small. So then try inverse norm of 1.9 divided by 2. And that's the one that works, I think, right? And that gets you 1.6465, so there's your. But we haven't done one like that. Just kind of look around that area. Ryan, is that good? Others, what else? What I noticed both times is I had to wait like 10 seconds for someone to ask a question. So I'm going to awkwardly stare at you for like 10 seconds. Are there any other questions? Well, Connor thinks they're easy. They must be. All right, go ahead. Keep working. 17, and I got no questions. So I guess. So keep going. Check your answers. Yeah. Wait, do you have questions?